Welcome to the lecture on network traffic monitoring. First, we will recall some basic information about firewalls and their configuration. The firewall, which is really a special kind of router, should control the network traffic rather than unobtrusively send senders and receivers packets. The firewall should send only those packets that were allowed and block all others. Which packets get through and which packets get blocked is specified by the rules. That is, the conditions according to which the firewall processes the packets. Such a condition, in the general form, looks as follows. Depending on the criteria the packet meets, it should be blocked or accepted. The information saved in the headers of the protocols of the lower layers of the OSI model is, historically wise, the first criteria that appeared. You can create rules that will filter the traffic on the basis of the sender's address, recipient's address, sender's port, or receiver's port. There are two approaches to creating such rules, or configuring the network firewall. The first says that the default rule should be a block rule. Everything that is not explicitly allowed will be blocked by the firewall. An alternative approach is to create a default rule that will be an allow rule. All traffic, except for packets explicitly blocked, will be permitted to pass through the firewall. Security-wise, the only effective way is to use the first approach. By default, everything that may threaten the security of computers that are to be protected must be blocked. The same intuitive rule should be applied in other security solutions. In the same way, you should prevent users from running any program of their liking and allow them only to install ones that are known to be safe. We will return to this issue later. When it comes to firewalls, we all realize that the default rule should be a block rule. Such an attitude isn't very popular in other aspects of computer and network security yet. Historically, the first method of filtering network traffic was IP header analysis. In its time, it was an effective solution. We're talking about situations dating back more than 15 years. Back then, computers exchanged data only if they had public IP addresses. No one used masks or more virtual and private addresses. Since then, the situation has changed, so these kind of firewalls are no longer effective. The use of the IP protocol has changed in the last 15 years. Another functionality that firewalls have acquired over the years is the ability to filter traffic on the basis of the headers of the fourth layer, the transport layer, protocols such as TCP and UDP. Because these protocols are responsible for establishing the communication channel, it was possible to filter traffic on the basis of, for example, port numbers. It was possible to allow web browsing and deny P2P traffic. It's all done by filtering on the basis of some constant features, for example, port numbers. It is assumed that a given service will always run on the same port. Firewalls filtering by transport layer protocol headers can usually check the session state too. This is the basis for the division of firewalls into stateless and stateful. If a trusted computer, located in your private network, initiates communication, the Internet connection firewall should allow it. This is due to the fact that the decision to connect to a less trusted server is consciously made by a trusted user. If, however, the server itself initiated a session, then it should be blocked. That would be an untrusted computer trying to connect to one of the protected computers. TCP session direction is crucial here. We will return to the issue of TCP session direction later in the lecture. The next step in the development of firewalls was to enable them to filter packets not on the basis of headers, but on the basis of data. You will notice that any firewall and almost every network monitor is equipped with the functionality allowing them to reassemble data. A set of data can be divided into several packets. Therefore, before making a decision whether a request is correct or if a file type is allowed, data from multiple packets must be gathered together. The data from these packets must be reassembled into one unit. This operation is computationally expensive and time-consuming. Therefore, application layer firewalls usually don't protect individual computers. They are specialized devices whose task is to protect in real time whole networks. A situation where it takes a minute, or even a couple of seconds, for a firewall to assemble packets together, examine their contents, and send them back is unsustainable. Application layer firewalls are rather expensive devices of large computational power. A separate issue that should be discussed is the issue of data encryption. With an application layer firewall installed and configured, another problem arises. That is, when the firewall should let packets through and when to block them if the data is encrypted. The firewall should be able to, first, decrypt the data and later re-encrypt it. Without this, the data would be completely unreadable for the firewall. The requirement to encrypt all data does not automatically improve the security of computer networks. It may sometimes have the opposite effect. Anyone who wants to send your private data outside will encrypt the data before sending it, having a good chance of fooling your firewalls and intrusion detection systems. Even though firewalls are not perfect, they are very useful and effective indeed, for the purposes they were created for. Firewalls should be used to control traffic between networks and subnets. You should use them to control the transmission of messages that are not needed outside, primarily diagnostic messages. Such a control should take place on a corporate network boundary or even the boundaries of individual subnets. While blocking the ICMP protocol on the subnet level can cause some trouble, blocking these messages at the boundary is reasonable. The firewalls are perfect for controlling traffic between subnets. Having divided the network into subnets, you can allow access to the subnet which hosts database servers only through the port servers listen on. In this way, you prevent people from using them for other purposes, for example, as file servers. Firewalls can be used also to block specific hosts or services. Most firewalls have a useful feature of generating traffic history. You can make a record of packets that pass through the firewall. This is useful in case you have to prove that an attack happened or track down the source of an attack.